Hello and welcome to Spring Office Hours, Season 3, Episode 5, Distributed Applications with Spring Cloud. My name is Dan Vega, Spring Developer Advocate at Broadcom, and with me, as always, is my good friend DaShaun Carter. DaShaun, how are you doing?
It's a wonderful time to be a Spring developer. That's all I can say. There is so much happening, and it just keeps on getting better.
It's a wonderful time to be a Java developer. It's a wonderful time to be a Spring developer. You know, I always see the tweets and stuff out in the atmosphere of like, oh, Java's slow and Java's old. And then like we have all these benchmarks coming out of reading in a billion rows in like a second. And I'm just like,
Not even a second.
yeah,
It's like 300 milliseconds, I think, is the number right now.
right. So it's just like, I try to like take it with a grain of salt because I know that it's not true, but people like probably wrote a hello world in Java 20 years ago and they thought it was too verbose and they just never kind of updated their thinking. So yeah, I take it with a grain of salt, but it's part of our job to get out there and tell people that's not the case. Java is evolving every 6 months. Spring is evolving right next to it every 6 months. So it's an exciting time. And I put this out on Twitter. I think we talked about it last week as too, just the things that are going on inside of Broadcom. I'm very excited about the future of Spring. So, we're here to talk about distributed applications with Spring Cloud today. We'll get into that in a second. But what have you been up to lately, my friend?
Well, I'll tell you, the top of mind right now is our buddy Josh shared a blog post with me from GitHub, the GitHub runners for Mac. The M1 Max, so ARM64 Max, that is now GA and available to use. So that has been top of mind for me. I'm trying to go in and figure out how I can build these ARM64 images using that runner, and I haven't gotten there. I haven't gotten through yet. I was hoping that all the same, Docker, CLI, Java, I was hoping all the things would be available on that. But I think the target audience was a little bit different. So I'm having to do a little bit of the brew update and install some of these things in order to get it working. But I'm excited. Up until now, I've been having a lot of fun using Circle CI, and I just want to see if I can get kind of a same over here on the GitHub Actions runners for ARM64 on these M1s.
Nice. So, yeah, I don't know. I did. Speaking of articles, I was trying to look here. I saw an article that was pretty interesting over the weekend as well. And I was just trying to find it. So let me see if I could find it here. All right, let me just do one more thing. I think I tweeted it out, so that might be more interesting. Yeah, so I saw this article over the weekend about something happening at Apple. Apple, I guess, apparently released or open sourced some new configuration project that has Spring Boot support for it. This is called, what is it? Pickle, and pronounced Pickle, PKL. It's a new configuration programming language. And I haven't had a chance to really dive into it yet, but apparently it's solving a lot of the problems of like static YAML and application.properties in YAML. Yeah. And the nice thing is this compiles down to both like YAML files, JSON files, XML, has like built-in validation. But what really stuck out to me was there was support for frameworks, and the only one on there right now is Spring Boot. So it came out right with Spring Boot support right away. And I know, I know Apple is using Spring in different places. So that's really exciting. So it was just exciting to see kind of something come out of the Apple ecosystem that's open source that has support for Spring Boot.
Yeah, I can't think of anything else that has come out of the Apple ecosystem that I've used. There's nothing that's jumping top of mind for something that's started inside of Apple and has, been let out into the public. Can you think of anything open source
I
from
can't,
Apple?
No.
So
but
just that
I'm
alone
on
is
the
kind of a
spot.
big deal.
Yeah.
Kind of a big deal, right?
Right. So that was pretty cool to see.
Definitely.
Yeah, but other than that, I just want to let you know this is a happy Monday. We are live streaming on a Monday. Same time, same bat channel every week. We usually stream here at 1 o'clock p.m. in the Eastern time zone. So if you're interested in joining us live, check out springofficehours.io. We have updated the website so you can listen to the podcast episodes right on there. And yes, we take this live stream and turn it into a podcast so you can listen to us on the go. And you can find all the archive episodes there, or you can listen to us on whatever podcast network you get your podcast from. And I have been jumping around, and I saw a couple reviews out there. So I just want to say we really appreciate that. The reviews on the podcast platforms themselves help. It helps like kind of push that up the bubble on the podcast platform. So we appreciate those reviews. If you have a minute, you want to say something nice or honest, whatever you want to say about us, that would be great. So.
Fantastic. Keep those questions coming in. Happy to address those. We're going to start them. We might not get to all of them, but we'll try to get to them. Today, we're going to talk about distributed systems and the whole thing
on Spring Cloud.
Yeah. Spring makes things easy, right? The Spring team finds patterns from people just like you, finds those patterns that are being used and turns them into something that's easy to consume. Deliver these advanced, mature strategies and patterns, deliver them in an easy to consume way.
So
that's awesome.
I think let's just jump into that. And I think I want to start from a high level. So we titled today's show Distributed Applications with Spring Cloud. Let's start with distributed applications. When you hear that word, what do you think of? Like what are you building that is a distributed application? What does distributed mean?
Yeah, I default right now to like microservice architecture. That's kind of what's in my head. Mm-hmm. These applications that kind of have a single concern that are easy to deploy independent of the rest of the system. And with that, the rest of the system is going to change independently, right? And being able to live and maintain an environment like that where different parts of this distributed system are changing independently of each other. And how do you navigate that successfully? There's patterns. Mm-hmm. How about you? What do you think of?
Yeah, and I think I like your kind of default there is like distributed applications is microservices, because that's a lot of what we talk about these days. That's a lot of what people are building, but there are other types of architectures when we get into distributed, right? There's some really good books on distributed architecture if you're interested in kind of reading more about that. But yeah, typically I'm thinking about microservices and, hey, I have a particular part of this application that needs to change at a different rate than others, or maybe it needs to scale at different levels of other parts of the application. And yeah, I think distributed applications too are not my default. Like, I think we've gotten into this. I mean, there's plenty of talks on this online, but I think we've gotten into this like everything should be a microservice when that's not necessarily the case, right? My default is build a monolithic application, and as I start to see problems, okay, maybe this is now a case where this could be kind of split out into its own service. But yeah, I think that's distributed applications. When we're taking monoliths and separating them out into different services, that sounds great because I can scale this one at a different rate than this one. I can deploy this one whenever I want to. But as we start to split those out, a whole bunch of other problems start to arise. It's not as easy as just like, let's take this and split this up, right? There are some problems that come up. And as you said, there are patterns when working with distributed applications. So we'll kind of talk through some of those today. We'll see how many we can get to.
Jonathan, thank you for joining. Jonathan also brings up the distributed monolith, right? Falling into this category of a distributed system. When I hear the word distributed monolith, I automatically think of all the things that we do wrong with our distributed systems. It's hey, yeah, we have these artifacts that are being deployed, but they don't have the right boundaries, for example. It's when I use that word distributed monolith, it's scalable and it's got some of the other cloud features, but it's not quite done with these best practices in mind, with some of these good boundaries in place. So yeah, that
Yep.
definitely falls into the category as well.
Cool. So that's kind of the distributed application side of things. The Spring Cloud side of things. So I when you hear like Spring Cloud, we kind of know what it is because we've dealt with it for a while now. But if if you're first hearing the term like Spring Cloud, you might think, oh, this is like a project for building cloud applications, and yeah, that might be the case. But it's more of less like all of these different patterns that come up when we start building distributed applications. Some of the things that we'll talk about today, like configuration management or service discovery or circuit breakers and so on. So these Spring Cloud is a collection of projects that help us kind of identify some of these patterns and provide us with a solution for those different patterns.
And that's the main thing is having that pattern. Yes, there is a vacuum running in the background, and I apologize for that. But have you read the paper around the Monolith from Google? We had a couple of.
I don't think I have. No.
I have not read the paper. What I do when I hear the word Monolith, I'm thinking of Oliver's project, the Spring Monolith, and all of the exciting things that it does. And it's basically giving us these boundaries and these rules, this guidance, guardrails for delivering monolithic applications, but in an approach where it makes it easier to separate so we can avoid that distributed monolith going forward. So I'm a fan.
Cool. I'm going to bring up this screen that you have up here. This is the Spring Cloud screen. So for those of us joining us on the podcast, we just went over to spring.io/projects and Spring Cloud. And then under Spring Cloud, you'll see all of the different projects that kind of fall under the umbrella of Spring Cloud. And right at the top, it gives you a nice description of what it is, what the features are. It says Spring Cloud focuses on providing good out-of-the-box experience for typical use cases that cover things like distributed and versioned configuration. So we'll talk about configuration. That's a big one. Service registration and discovery, another really big one. Things like routing, service-to-service calls. I need load balancing. I need circuit breakers. I need distributed messaging. Short-lived microservices, consumer-driven and producer-driven contract testing. So a lot of really good features, but a whole bunch of projects on the left side. I think a good place to start might be configuration, because that is something we need in all of our applications. So there is a project called, now again, so actually, where do you want to start here? If you're building a microservice, and well, I guess there's two approaches to this, right? If you're tearing down a monolith into services, that's kind of one path. If you're just starting and for whatever reason this is going to be its own service and you're building this one service, maybe you're not pulling in any of these yet because you don't have any of these patterns to deal with. You only have a single service. But if you have a bunch of services, one of the things you might need to do is get configuration from a central place. Instead of having 10 microservices that have all of their own configuration, you probably have all of this configuration in a single place, and then each of the microservices can pull from it. Because one of the things you don't want to do is duplicate that across 10 different services, right? They probably all share some configuration that they would want to read from. So can we start with Spring Cloud config? Where's config server? Yeah. So tell us a little bit about Spring Cloud config. What is this?
Well, let's first, talk about one of the things that we kind of assume. I assume that most people that are doing distributed systems are aware of the 12 factors that came from Heroku. This idea that your config shouldn't live in your artifact. It should be separate. It should be provided by the environment. And Spring Cloud config makes this easy. It makes it easy for you to get your configs from different places, whether it's from environment variables. You can have it backed by databases. You can have it backed by GitHub repos. And this is just a pattern for making it easy. Where we're at and maybe this resonates with somebody. I remember times, and I've seen customers that they have different application properties files that they are injecting into their jar files or their war files that they're taking to production. So there's a change. The artifact that is being tested by the developers gets modified and gets different configurations injected into it once it hits dev or test or stage or whatever the environment name is. And this has caused problems over the years. We've learned that this is not the right way to do it. We have an artifact that should be able to be consistent from dev to production, consistent across the environments, and being able to change the properties externally, providing those properties by the environment. That's a good idea. So this is a project that allows us to do that. So imagine your application, instead of having to expand or explode that jar file and put in new application.properties when you move from test to prod, your application just knows, I'm going to get all of my configuration properties from the environment that I land in. So the artifact doesn't change. And it makes it easy to change those properties, even after you've deployed. Being able to change applications properties using the same artifact, instead of having to deliver a new artifact in order to get the new properties, being able to just change properties at runtime is another option, another capability that we get. How often, raise your hand, if you've ever had to just change, like, hey, I want to change logging level, and been forced to deliver go through the entire software supply chain to deliver a new artifact that just has a property change. Right? This is a bad idea. This is something that Spring Cloud Config can help us with.
Yeah, speaking of logging levels too, you can change that through the actuator, which is pretty cool. That I've done that before, which is pretty fun. So if you're on start.spring.io and this application is going to be one of the apps talking to the config server, that is the client. Then if you're searching on there, you can search for Spring Cloud Config and you'll see config client come up as one of the options. This is a client that connects to a Spring Cloud config server to fetch the application's configuration. So you'll basically set that up as a client. If you already have a service and you need to add it to it, you can add that as a dependency later. And then you do some configuration to say, like, this is the client and this is where the server is that we're going to pull down from. And as DaShaun said, that could be a number of sources. One of the ones I've kind of defaulted to in the past is like a GitHub repo, because then that's not like something that has to be like redeployed. That's something anybody with GitHub access can talk to and change properties. So I just got a question there too. It says, is changing properties through the actuator actually recommended? So it just depends, right? One of the things, DaShaun and I always say, like, one of the first starters that we pull into a project is the Spring Boot actuator, because sooner or later, like, you're going to need that. But everything is kind of locked down by default. You have to expose a lot of these endpoints, right? And so I think one of the common mistakes that we mentioned on the last episode was, don't just expose everything, right? We don't want to expose all of those to the entire world. But if those things are exposed to a certain set of people, maybe behind some kind of security or firewall, whatever, if only certain people in your organization have access to it, then I don't see any problem with that. Obviously, you don't want to just open this up and allow anybody to change log levels, but if there's security involved, then you could do that. But if you don't want to do that, doing it through configuration is something we could definitely take a look at as well.
And I think that brings us to another good project, interesting project, the Spring Cloud Bus. This is a way, for example, with our configs, I can have my applications deployed at scale across multiple environments, and using something like a Git-backed configuration, I can make a change in a Git repository, and my configuration server, my Spring Cloud config server, can say, hey, I noticed that the state has changed. I noticed that this property has changed, and I can send out a message over the Spring Cloud Bus to say, hey, Spring Cloud config clients, you've got a new property. Use that new property. Refresh, get the new property.
Refresh, yeah.
Again, another way of making that easy. So you don't have to go and restart those applications in order to pick up new config. You can be making these types of config changes at scale at runtime. Spring Cloud Bus is another great project in this umbrella of Spring Cloud, right? There's tons of projects here, and it's kind of an umbrella for these things. these concerns, these patterns that you have when you're going to production.
Yeah, and I think the whole idea behind today's show was to just start talking about them at a high level, because I think if you get thrown into the documentation here under Spring Cloud and you see all these projects, like, oh my God, like, do I need all of these? Do I got to learn all of this? And the answer is no. Like, you'll start to use these as building blocks. So we talked about configuration being one of those building blocks. Another building block is discoverability, right? So when we get into distributed applications, we have our services in different places. So we may have like 5 or 10 different services, and we need to discover some of those services because they're not always at a specific location, right? Like I may have service A over here and service B. Service B may scale, infinitely. So we can't just hard code something in there. So I got to be able to say, hey, go find me service B. I just need an instance of it. I don't care which instance it is. If you only had one instance of it, then sure, you could just hard code that in. But part of the reason we have distributed applications, right, is so we can scale them independently. So in service A, I want a discovery service to say, go out into this network of services that I have and find me an instance of A. I'm going to call it service A or service B. I don't care where it is. You figure that out for me. That's kind of the idea of service discovery. What would you say to that, DaShaun?
Yeah, at scale. I've got the same case. I got tons of these service B. One of the other things that happens is you want to make sure that you're calling something close, right? You can have this discovery implementation where you can actually say, hey, where are all the service Bs? And on the client side, I can say, hey, I would like to, get that directory of all these services, but I want to make sure that I'm calling the one that's closest to me. You can have the zone awareness, the region awareness, when you're taking things to the cloud. So you're not doing the ingress and egress to some other cloud, for example, getting hit, triple for these costs in the cloud. Yep. So this discovery mechanism is a great way to, find out where they are without having to do a lot of extra work. You don't want to also, right, what we would have done, say 10, 15 years ago is we would have just set a global load balancer in front of all these services across all the regions and availability zones that we have. And we just say, hey, give me service B, and you would get one of them. But you really didn't have control on where that one was. So you might have inconsistent performance. Right. So, and this is the other thing. They're like systems like Kubernetes have this kind of built in. It has its own discovery, right? Spring Cloud is making it so you can have that same pattern when you're not running on Kubernetes. You can take this service discovery pattern to your virtual machines, to your devices on the edge, and you can have the same patterns. And that's what this particular project. Now, there's a couple of options here under the Spring Cloud umbrella for service discovery. The first one is the one that came from Netflix OSS, called Eureka. Yep. Right. So this was born inside of Netflix. They open sourced it, and now they've actually turned it over to the Spring team, and it's being maintained and carried forward by the Spring team. There's another option, again, providing similar pattern, just a different implementation. Spring Cloud Console can also be used for service discovery. And a lot of times we hear the question, which one should we use? Which one's the better one? And I've heard both, right? It depends on your circumstances. It depends is the main thing. Yep. But they both have strengths. And I think the thing that it depends on the most is, what is the rest of your environment using? What's the rest of your organization using?
Right. Cool.
So, there's discovery.
So that is discovery. Obviously, there's a lot more that you can deal with within that, but that's just another pattern that will come up. Another pattern that we've talked about on this show before is the idea of a gateway. One of my favorite Spring Cloud projects, which is Spring Cloud Gateway. So Spring Cloud Gateway serves gateways in general serve a few different solve a few different problems. One of which is, okay, we have all these microservices out there. Say we had 10 services, and we have all these clients that need to talk to these services. these clients don't want to know about all of these 10 independent services because it's really just Dan and DaShaun's e-commerce application, right? So they just want to call Dan and DaShaun's e-commerce application, and we can behind the scenes figure out which service we need to route traffic to. So now the client only has to call one API instead of 10 different places. Also, so that's one function that a gateway does. It will take requests and then route them down to other services or other systems, and it could modify that request and that response for the client. So that's one thing. Also, you want to have some of those, whatever some of those services are that you're going to do at a gateway level, you would want to do it in one place. You wouldn't want to do security, something like security that's very important at 10 different places, right? You're just duplicating like common logic. So things like security or logging or observability, that kind of stuff. Those you would do at a gateway level. And so Spring Cloud Gateway comes in and gives you this really easy way to do this. So before, we were doing this kind of at the network level, right? There's some hardware gateway in place. And if you wanted to make a change to this, you had to put in that ticket in the system. And we all know how long that could take, right? Like it could take days, hours, days, weeks to get that in and approved. And now comes along something like Spring Cloud Gateway, which is software gateway. And it allows us to write the configuration in code, but we can also do it in like YAML configuration or property configuration. So it's very intuitive to look at and go, what is happening in this application? Oftentimes you don't even need software developers to make that change. Somebody who can just take a look at configuration can make that change. So yeah, Spring Cloud Gateway is great, and it comes in two flavors now. So it used to be only a reactive application server, because when you're talking about taking a request in and forwarding it to some other service, you don't want that, when I'm talking to something over HTTP, that is a blocking client, right? And so now we get into the whole, thread per request model and talking about, using the resources that we have. And that's where Reactive really came in and said, okay, we're going to send off a request and forget about it. We'll get a response back sometime later, and then we can worry about the response then. And now that we have virtual threads in JDK 21, Spring Cloud Gateway was updated to have another version, which is Spring Cloud Gateway MVC. So now you can write your Java code in an imperative style, not a reactive style, and take advantage of virtual threads.
Yeah, before this, we had Zool, right? And that was threaded. That was the threaded model. And we ran into problems at scale, right? So this was the answer, right? Is we were able to have more scale at that gateway layer, handle more requests, and scale better. But now we're kind of circling back. So I want to address Dan Ido says, like, hey, isn't that the job of ingress? Right? That's what it used to be. It used to be that if I wanted to route to my service A or my service B, I had to open that ticket, and I was doing it at like an F5 or some global load balancer. And we realized that, hey, for team A and team B, we don't want them to have to, make all of these tickets and open these routes at the network layer. We can just say, hey, send traffic for team A's project to team A's gateway, and then team A can configure the routing for that application, that project, independently of the networking. All the traffic comes here, and then you're distributing kind of the access and the permissions of how to route your traffic. It also gives you another feature of, you can do interesting things like canary deployments, weighted load balancing as well. So we have all these features that aren't now at the network layer, they're down at my application layer, which is super valuable.
So you said a word a couple times there, load balancing. That's kind of another pattern. What is load balancing for those who may not know what it is?
Yeah, if I'm wanting to handle, I apologize, I need to turn this. If I have multiple applications, or I'm doing things at scale, then sometimes one instance isn't enough. So how do I send traffic to 2 instances of the same application in a smart way? right? How do I balance the traffic across those two? There's different mechanisms, different approaches where I can do like round robin, or I can ask those applications, are you okay with accepting more traffic? How many connections are already open to each instance of that? And Spring Cloud Gateway can help deliver that traffic to the right place at the right time when you combine it with something like service discovery. Say, hey,
Awesome.
who's not handling a bunch of traffic right now? Because I want to
Right.
send this next request to them.
Yep. Cool. Any other questions?
Here's
So
another good question
yeah.
on this topic. Like, what's the difference between this reactive and the MVC one?
Yep. So we talked a little bit about it, but when we get into writing some of these configurations at the Spring Cloud Gateway level, like we set up these route handlers and these predicates and these filters, and we say, hey, everything that comes into /API/products, this is the service we're going to send it to downstream. You can do that via configuration, whether it's properties or YAML configuration, right? You can also do a lot of this in code. So you can write this configuration in code. And one of the big differences is that in the reactive world, and the default one until this year, you had to write that code in a reactive manner. So if you haven't written reactive code before, there's a little bit of a kind of learning curve there. And it is an all or nothing. But it solved a real problem of not having to block those threads when it was performing a HTTP request, right? So if you're using the reactive one and you need to write your code, you have to write it in that reactive style. So then MVC came along and said, okay, well, for those users who want to be able to write configuration in code, but still use the imperative style of code that they're used to writing, now you have an option with Spring Cloud Gateway MVC. And it's not a one-to-one mapping. I think that's something important to point out. The Spencer and the team did a really good job of kind of porting over a lot of the logic that is in Spring Cloud Gateway to the MVC version of it, but it's not an exact replica. There may be things that the reactive version is doing that the MVC version isn't doing, and vice versa. So you'll want to just check out the documentation on that.
Yeah, good questions here. Jitter Ted, hi, welcome. Jitter Ted says, can I just use Spring Cloud Config without using other Spring Cloud modules? The answer is yes, right?
Yeah.
You can have a config server and a config client. You'll need a client to access that config server. But yes, you don't need any of the other modules in order to use that.
Yeah, and I think that's one thing we're kind of talking about today, right? Again, if you look at the Spring Cloud documentation, there are all these projects, and it may get a little overwhelming. Like, oh my God, how am I going to build something with all of these things? And like, you don't need all of these things. Recognize one of these patterns in your application and just pull from that one particular project, like configuration, like discovery, like a Spring Cloud Gateway.
And another good question, kind of in the same thread. Malik, I think it says, is it possible to have two configuration servers load balanced without the Eureka service for discovery? Or is service discovery in that case recommended anyways? It is possible. So again, you don't have to have the service discovery in order to use a load balanced config. And there's kind of two approaches here, depending on what your system looks like. We have kind of a config first approach where there's a known address, perhaps a load balanced configuration server address that all of your applications know to go to myconfigserver.mydomain.com. And that's load balanced across two or more in order to go get your configuration. And then from there, it'll say, hey, here's where your service discovery is or other properties. But you also have the discovery approach where you can say, hey, discovery.mydomain.com. We're asking for the discovery server. Where are my config servers? So there's a config first approach, and then there's a discovery first approach, but they can be done independently. You don't have to use them both. They can be used independently of each other. And then that kind of leads into another good question down here where we're saying, hey, like on Kubernetes, do you even need to use discovery services if you're doing container orchestration with Kubernetes? No, Kubernetes has its own discovery services in place. But what if some of the services that you're wanting to reach out to don't live in Kubernetes? What if they're not accessible via the Kubernetes discovery? What if you've got systems that are running out on the edge or on VMs or in another cloud and you can't use the Kubernetes only discovery? That's why these projects are still super valuable. Not everybody's using Kubernetes, and there might be people here that can't spell yet Kubernetes. So, right, there's options here. There's patterns that we're taking to production, and we're trying to make it easy, whether you're on Kubernetes or not.
Yeah, and we were talking about this earlier, kind of offline, but some of these patterns do exist within Kubernetes. Like there's an idea of a gateway within Kubernetes, but you may want to use something like Spring Cloud Gateway in Kubernetes. And I know at a commercial level, we do have a Spring Cloud Gateway for Kubernetes, right? So just because you don't need it in a Kubernetes environment doesn't mean that you can't use it. There are definitely certain patterns or instances where you may want to use it.
Yeah, the other thing is, in my head, when I'm delivering applications, I don't typically design it in a way that it's specific to a platform. Like I don't want to deliver an application where this has to run on Kubernetes, where this has to run on VMs. I want, this cloud native word that we've probably heard a bunch. There's some patterns that we can do to make our lives a little bit easier as we go to production. And there's this concept that I think a lot of people are latching onto, where it shouldn't matter. As a developer, I shouldn't really care if it lands on Kubernetes, if it lands on VMs, if it lands on Cloud Foundry, if it lands on Nomad. I shouldn't really care if I'm doing things, if I'm delivering this application with some good practices in place. Where it lands shouldn't really matter. I shouldn't really be concerned, but I've got to do some certain things in order to have this ability to be deployed to any one of these platforms or architectures.
Mm-hmm.
And this is one of the things that we can do.
Yeah, I see another comment or question here. I found it. What I meant earlier was at refresh scope that adds a refresh endpoint to a service to reread Spring Cloud configuration properties on demand. So yes, there is an at refresh scope you can put, say, on a controller that reads in some properties, hit an actuator endpoint, and that kind of pushes it out and says, hey, update your values because something has changed.
Yes, yes. And for those of you that don't know, Kubernetes is oftentimes abbreviated K8s, for those of us that aren't the best at spelling. So yes.
K8s, yeah.
K8s, K8s.
Okay, I think we can talk about another one here. I think this may fit into one of the questions that I saw earlier. So if we go down to Spring Cloud Openfeign, maybe this can kick off a discussion about clients in general, right?
Yep.
So Openfeign's been around for a little while, and this is a declarative REST client, it says. Feign creates a dynamic implementation of an interface decorated with JAX-RS or Spring MVC annotations. And for the longest time, if you wanted this nice declarative client, you could use something like Feign. So you create this interface. I have this interface called name service. I annotate it with @Feign client, and I just provide the contract, and then this gets turned into an implementation at runtime. So this was something you could do for a while. And then in Spring Boot 3, we introduced HTTP interfaces, which is a similar approach. But you could do this just in a normal Spring application without pulling in, say, a separate dependency like Spring Cloud Openfeign. Now, when we did this in Spring Boot 3.0 and Spring Framework 6, this was first relied on the web client. So the web client was part of the reactive dependency, the Spring Web Flux dependency. So if you wanted to use HTTP interfaces, you had to pull in this web client or this Web Flux dependency. And that was fine. The web client's great, but it also, you had to pull in this dependency to use it. And if I'm in a Spring MVC app, why do I have to pull in that dependency? Then in Spring Boot 3.2 came the REST client, and it was similar to the web client. It was this nice declarative, but this was for imperative style applications. It was a blocking API, similar to the REST template, but this much more fluent, easy to read API. And now that the REST client is there, you can use HTTP interfaces in Spring Boot 3.2, and it just uses the REST client underneath the hood. There's no need to bring in that extra dependency. So I'd have to look at the features. Again, everything's not one-to-one, but what I would say going forward is you could probably just reach for the REST client or the web client, especially in a Spring Cloud Gateway MVC app, right? You have access to the REST client. Just use that instead of bringing in this dependency. So I did see a question earlier about the web client, and I just want to bring it up. Where was that? I think it was right away. Yeah. Can you please shed some light on the web client? I'm always getting confused with web client. So the web client is just a way, it's an API to be able to talk to other services. If you're in a reactive stack, so you're bringing in something like Spring Webflux, and I need to talk to DaShaun's e-commerce service in my app, I'm going to use the web client that has a nice API, like you say web client.get, you pass it a URI, you say talk to DaShaun's e-commerce application. Here's what I'm going to get back. I'm going to get back this list of products, and that's what we're going to return via, say, a flux of products, right? So that's the web client. It's a way, it's a asynchronous client to talk to other services, and that was built in the web stack. And as I just explained, there's now a similar client on the MVC side called the REST client. So I hope that answers that question.
One of the other things I want to point out is if you're delivering applications to one of the hyperscaler clouds like Azure, like Amazon, like GCP, then there are libraries, there's projects here that are going to make that easier. Adapt to the infrastructure, adapt to the things like their property servers and their discovery servers and the things that are providing capabilities like zone awareness and region awareness to your application. These are projects to help with that, so that you can get the idiomatic way of doing things in these different hyperscalers. We have projects that help with that as well. So there's Spring Cloud Azure, Spring Cloud Alibaba, Spring Cloud for Amazon Web Services, and Spring Cloud GCP. Ways of interacting with the clouds in a deeper level. So instead of just the things that are similar across all those clouds, getting some of those cloud-specific benefits from the cloud providers. Some of the other projects here that I love and use, Spring Cloud Function.
I was just gonna say that one. We're on the same wavelength here today.
It's like we've been doing this for a while. Spring Cloud Function goes a long way. Tell me, why do you reach for Spring Cloud Function?
Yeah, it's a nice way to kind of write your business logic in for like functions that I'm going to deploy to different services, but I don't have to write them as I'm writing them for a specific service. So what I mean by that is I want to write a function that does something, and I may deploy it to AWS Lambda. I may deploy it to Microsoft Azure, right? I may deploy it to Google Cloud to their functions as a service, because all the major service providers have this idea of function as a service, right? A piece of independent code that can just run on demand. And so I guess to kind of step back on that, if you have like larger applications that are constantly running, taking throughput, like heavy usage, then maybe this isn't the case. Maybe this is not something you would do. But what if I have an example where I just need some code to be able to react to a request and then shut down? Somebody actually asked me this on Twitter over the weekend. I was talking about a project that I'm trying to work on here, and it was like, okay, well, if this is just a side project, why would you deploy this to something like AWS? That could get very expensive. And I said, yes, it could if I have a server up, running all day long, every day, 365 days. But if I'm just starting out as like a hobbyist, I'm probably not getting a lot of traffic, right? I can take this thing and run this entire app on something like AWS Lambda and have it scale to zero. If it doesn't need to take a request, it can just go down and it's not costing me any money. So that's kind of the idea of function as a serverless. Yes, somebody mentioned a comment often called serverless. Because you don't have to worry about service. I don't have to provision servers. I worry about the code. And Spring Cloud Function lets me worry about the code independently of the targeted runtime. So I just get to write a function using Java functions, right? And then the build system will turn it into the artifact that it needs to be for, say, AWS Lambda.
Reed has a good question, right? Again, Harpreet, my head's going the same way. The relationship between Spring Cloud Function and Spring Cloud Task. Spring Cloud Function is usually attaching to an endpoint or an event, and it's listening. Spring Cloud Task, on the other hand, it might be something small that's just going to operate once and shut down. But Spring Cloud Task is something that's scheduled. That's the difference. So I want to check my stats of my fantasy team, and I want to do that every hour. I don't need a server up running 24/7, or maybe I only want to do it every day, whatever it is. I can schedule a Spring Cloud task to run on my Raspberry Pi that calls out to get my stats and pull them down into my database. So same thinking of in these terms of small units of operation that we're going to run once and then they're done. They don't need to be running 24/7. So similar in that sense, but different in how they are implemented and how they're called.
Yep. And then so these are just individual functions. I just want to kind of make this clear, but these are like individual endpoints that you would write. Now, if you're writing like a whole REST API, REST service, right? You have 10 functions in there that you want to call. You may not want to deploy those as individual functions. You can also write your Spring MVC apps and deploy those on something like AWS Lambda, which is really exciting because again, as a hobbyist, as somebody who just wants to put a project out there, but I don't want to pay whatever it sometimes it gets really expensive, right? I don't want to pay that per month when it's just something I'm like hacking on. So put it on something that can scale to zero and only come up when you need it to. So yeah, just
I don't
some
have cloud
exciting
money.
things to think about.
Yeah, I don't have cloud money.
I don't.
So-
I have kids and a wife, so I don't have
Yeah.
cloud money.
So one of the other ones that I reach for often is Spring Cloud Circuit Breaker.
Yes.
This idea that like, what if I'm expecting a service to be there and that service isn't there, or there's an error or something happens? What do I do so that I don't overload that system? Maybe it's a third. Maybe I'm trying to be a good consumer.
That's never happened, DaShaun. A service has never in the history of services been down by just accident.
The
Right?
cascading failure issue, right? If I'm realizing that, hey, there's something going on, I can, as a consumer of some other application, I can say, hey, you know what? I'm gonna break the circuit. I'm gonna open the circuit so that I don't make a call there anymore until that service says, hey, I'm healthy and I can accept more traffic. But I want to have a good experience. I want to have a good experience for my customers, the consumers of my service. I open the circuit and I give them an alternate endpoint. I give them alternate information. This is, hey, we can't make this call right now. Handle this in a nice way. So here's your answer, your response that says, hey, that backend service in there, or maybe it's some defaults.
Maybe it's a cache, right? Maybe you're using
maybe it's
Redis
a
cache
cache.
somewhere, and you're just like, hey, let's pull like the last known list of things that we can display to them.
It gives you this ability to prevent the cascading failures, to give a good, good feel, a good vibe for the user of your service, where you can say, hey, The one that I always fall back to is like Netflix. Like if you go to Netflix and it's got your recommendations, if that backend service was down, it's going to give you the
Most popular,
recommendations are going to be the
right?
most popular ones, and it's not going to be specific for you.
Hmm.
But they've got it. You still want that experience. You still want that screen to show up with some recommendations,
Yeah,
right?
we
You
don't
don't
want it
want
to
to just
just blow up that whole
yeah.
screen, right? Like that service shouldn't be down because one other service is down.
So Spring
And
Cloud
so,
Circuit Breaker makes this pattern really easy.
yep.
It gives you this ability to say, hey, how much time am I going to give for that back end service to become healthy? How am I going to check that that
Mhm.
back end service is ready for more traffic? And how am I going to respond to traffic when that back end service is down? It gives you these things in a pattern that's easy to consume.
Yep. Yeah, and I hope part, we've said it a couple times today, but I hope what we're trying to do is make you just aware of some of these projects. You don't need to go into every single project thinking I'm going to like I need these 15 things. But as you're starting to build out your applications and this problem comes up, maybe it'll come back to this conversation. Oh, I remember DaShaun and Dan talking about this. Let's make sure that service downstream doesn't fail. Spring Cloud Circuit Breaker can solve that problem. So we have another question here. Let me see from Julius. It says, sorry if I'm asking this question a little late. Is the new Spring 6 HTTP interface using the @HTTP exchange annotation identical to the Feign client interfaces? No, it's not identical. But it will replace that, right? Because you don't need to bring in Spring Cloud Openfeign as a dependency. I would say if you're doing something very specific in Openfeign, I don't know what that is. Like somebody brought up the idea of the example of like load balancing that is built into Spring Cloud Openfeign. But if you're in something like Spring Cloud Gateway MVC, you can use the @load balanced annotation with the Spring 6 HTTP interfaces. So that replaces that, but it's not a one-to-one, right? So I would say look at the examples of what you're trying to do and see if there is a way to do that in HTTP interfaces. But yeah, I don't know the answer to this, but my default is, go for what's built in. Right now, the REST client, the HTTP interfaces are built into Spring Framework. Openfeign is another dependency you have to bring in. So unless it does something very specific that you need it to do, I would use the REST client.
Fantastic.
Cool. Another
Great
project I
questions.
wanted to talk about, actually a couple of them. So one is Spring Cloud Sleuth. I just want to mention this. So this was a way to do distributed tracing in the past. As you could see at the top, I think is there a mention of this in there? I
Yep.
don't
The
know if
core of
there's.
this project got moved to micrometer
Yeah.
tracing, and instrumentations will be moved to micrometer in all respective
So
projects.
so now this is built into the Spring framework. So if you're doing some distributed transaction or distributed call to, like, say in my application, I'm calling two different clients. So I call from service A, I call B, and I call C. I would, I want to know what that transaction looks like. I want to see that call, see the other call. Maybe we aggregate those results together and return those in a response. I want to see that. You no longer need to bring in something like Spring Cloud Sleuth for that to happen, as long as you're on Spring Boot 3, Spring Framework 6 and above, right?
Is
Um,
distributed tracing, is that an advanced use case anymore, or is that kind of a table stake?
when we're talking about the applications that we're building today with Spring Cloud, yeah, I think that's something you absolutely need. So again, goes back to the default of include the actuator, learn about the observability stuff in Spring Framework 6 and Spring Boot 3. And yeah, take advantage of that. Be able to see what's happening, see where it's failing. And yeah, Jonathan is of course on with us, and we're gonna talk to Jonathan more about that very, very soon.
So here's a question from Yuri, and I get this a lot. What's the best way to use a bug fix from Spring 6.1.4 milestone? Just any, like, what's the best way to get a bug fix that's already out, but it hasn't yet been released to my release train? What's the best approach? And the question is adding framework bomb M1 or using the Spring Boot 3.3.0 M1. What's the best approach? And that's a good question. If you're broke in production and you need to pull that, Ben, what would you use? Because Jonathan responds like, hey, just wait till the 15th for that to come. But if that bug is causing you an issue in production, what do? You're just like, hey, I can't wait. So what's my approach here? What do we recommend?
Yeah, you have a couple different approaches. I mean, one for me is you could always build, Spring Framework is open source. If you want to build an artifact on your own, you could pull down the source code and build that. If you absolutely have to have something that's in that particular milestone and it's not out yet, that's probably your best option. But that's not easy, right? That comes with its challenges. And yeah, and then you can just wait until, you could do that, and then when the next milestone comes out, make sure you update to that milestone. But yeah, I would say waiting for the next release would probably be the best. Jonathan says, in that case, I would do the smallest change, which is a framework upgrade. But if that makes it broken in another way, bring in boot M1.
And I agree with this. So we are oftentimes on the show, we're always talking about calendar.spring.io. The reason that we can kind of look ahead when you're on the edge, when you've got applications that are relying on bug fixes and you're aware, you can look at the calendar.spring.io. You can find out when these fixes are coming, but we want to make the smallest changes possible. If you can wait for the release train to catch up, then that is definitely the recommendation. But if you can't wait for the release train to catch up, I'm gonna default to Jonathan's advice here. Make the smallest change possible. But if you pull in that framework change, that M1 framework change, it hasn't been tested against the rest of your stack. That might be an issue. So be willing to test and evaluate that change, but that first, and if that doesn't work, then I'd bring in that M1 bomb. Great recommendation. And I agree. And actually, you know what? Because of the release train and the way that is, I'm expecting that bomb for the milestone is already going to have testing in it. So I might lean into the bomb, but actually I trust Jonathan more than my opinion, so never mind. I'm going to stick with Jonathan's approach.
Oh. All right.
So Yuri says boot M1 is still using 6.1.3, it seems. Just check the repo. All right, so yeah, we got options. So switch to that smallest change necessary. But Yuri, you know that you can always reach out. That one's going to take a little bit of extra time. Reach out, grab some time on my calendar, and I'm happy to dig in and take a look with you.
Okay, I want to mention one more project before we kind of say goodbye, and that is Spring Cloud Stream. So one of the other patterns that kind of come up in distributed applications is now that everything doesn't live in one app, it's kind of separated into multiple apps, right? We probably need to talk to other services to get data. So my orders service will probably have to talk to my product service to get information about products. It's not all in the same application anymore. So there are ways to do this, right? And I saw this question come up on Twitter the other day, and this is the way I answered, and I would be interested to hear your answer, DaShaun. But there are different ways to talk to services. One is through a client call. Like I need to make an HTTP request to that other service, and I need to get that response. Another way to do this, to communicate in microservices, for example, is by using messaging systems. Things like RabbitMQ, Apache Kafka, there are many of them, right? So somebody had asked, like, when do I use a messaging system versus when do I use just call an API? And my simple response was, if you need a response, then you're going to use a client call to make a call and get a response right away. If you don't care about getting a response right away, immediately, then you could use a messaging system. And I know that's a kind of simplified version of an answer for that, but I'd be interested in hearing your answer on that.
Yeah, it depends. It depends on the system.
Depend.
And we have these options, right? You've heard, or perhaps you've heard of event-driven architectures. This idea where if we've got these third-party systems, we've got things like Spring Cloud Circuit Breaker in place. Sometimes it's more important to get the right answer than to get an answer right now. So if we have these event-driven architectures where we're saying this thing happened, everybody that needs to know can know, and they can take their action accordingly. Or I need to have an answer, right? There's different architectures that are out there, and there's not a better one. It depends on your experience, your organization, what you're trying to accomplish. There's a lot of things that need to go into this practice.
Yep. And they have different features. Now, we're talking about this event-driven architecture, and there are these different messaging systems, right? We mentioned Apache Kafka, RabbitMQ, there's Azure ones, AWS, SNS, Apache Rocket. So there's a bunch of them. Spring Cloud Stream does this really cool thing where it's like, okay, I'm building these event-driven architecture systems, but rarely in an organization do you see, okay, everything in our application, everything in our system uses RabbitMQ. That's it. We're standardized on RabbitMQ. That's what we're going with. And more often than not, in larger organizations, you'll see different messaging systems. And trying to interface with those can be a little bit challenging in just a normal application, right? And so what Spring Cloud Stream does is make the idea of those things, those messaging systems as different binders in your application. And you could declare hey, we have this one system that is written using RabbitMQ, and we have this other messaging system using Kafka. Those are the binders, and Spring Cloud Stream makes it easy to kind of interface with all of those different messaging systems. So definitely a cool project to check out.
Yeah, it's almost, again, the Spring team has done a great job of providing these abstraction layers over these different architecture decisions. Lately I've been talking about how Spring data over top of my RDBMS or my NoSQL databases provides this kind of layer of abstraction that I can easily understand, I can get experience in, and I can move across these different data stores with some comfort level. And Spring AI is now doing that for these different large language models. But Spring Cloud Stream does that same thing for these messaging implementations. Once I understand that abstraction layer, it's easy and comfortable moving across different implementations.
Yeah, that's a really good point. Especially in the Spring world, right? There's a lot of different implementations of kind of the same thing, right? There are different abstraction layers, and understanding the right level of abstraction layer to choose is an important decision, and it really is based on a number of different things, right? And so yeah, just understanding what's available to you will probably give you a little bit more insight into which one should I reach for.
Fantastic. Well, we are running up to time, and we've had a ton of great questions, and I love this community. Jonathan, again, thanks as always for answering questions. So a lot of the questions that we didn't get to talk about were addressed in the chat, by the chat. Thank you so much.
Yeah, so if you want to watch a replay of that, head over to the Spring Developer YouTube channel. Check out the live feed there. All the replays for our shows are on there. Also, if you want to listen to them, you can listen to them on whatever podcast network you get your podcasts on, or head over to springofficehours.io. We have a new website up. It's not going to be the new website. It's just the new website, DaShaun.
Not the new.
But this one, okay. Not the new, just the new. But it does give you the ability to now just kind of listen to archived episodes right there. So I like it. I like what we're doing. I like where we're going, having a lot of fun. And I thought today was a really great conversation, because just understanding what some of these projects do and what problems they solve is half the battle. Now that you know that particular project solves that problem, now you could go start to investigate and let me look at this and figure out how to use it in my application. But if you don't know what problems they solve, then it's hard to know where to reach for. So I thought this was a real fun conversation today. We have some exciting shows scheduled. Next week we have a special guest. We'll talk more about that on Twitter and as we lead up to the show, but we have a special guest on testing testing is, I know Ted will be there because Ted loves testing. But that is an important subject, and we'll have a lot of fun with that one as well. So with that, happy Monday. I hope you guys learned something new today, and we will see you in the next one.
Thanks.